Hey everybody, this is Mr. Longo here, and we are going to review solving systems of linear equations. Now, back in the day, you learned how to solve by substitution and also elimination, which is also known as linear combination. So either way you learned it, elimination and linear combination are the exact same thing, same steps. So what we're going to do is we're going to solve the exact same question twice. We're just going to do it in different methods so you can see the difference. And unless the directions state which way to do it, to me it doesn't matter. Just make sure you know how to solve for x and y and we are good to go. But you should be familiar with both ways just in case, and also because each method has its benefits depending on which way the equation is given. Okay? So let's start. Substitution. The first thing you're doing with substitution is you need to get one of these two equations to be either y equals or x equals. It doesn't matter. Some are easier than others. In this one, it's going to be easier to get y by itself because there's no dividing by 2 or anything that's required to get y by itself. So all you have to do is subtract 2x from both sides to get y by itself. So this equation is y is equal to a negative 2x plus 5. So that's your first step, is get one variable by itself. After you get that variable by itself, what you need to do is substitute what y equals into the y of the other equation. Okay, so you don't write the y again. What you're trying to do is get rid of one of your two variables. So then we just substitute it in. So 3x minus 2, and as soon as your y comes up, you want to open up some parentheses and write this expression for y. So y is equal to a negative 2x plus 5. Here's your negative 2y, so here's your negative 2 times a negative 2x plus 5. So that just took the y placeholder. And we're still equal to 4. But now you can see your equation is one variable. So you can solve for x just like you have in the past. So now we just solve. Distribute your negative 2. So 3x plus 4x minus 10 is equal to 4. And now combine our like terms and solve. So we have 7x minus 10 is equal to 4. Add 10 to both sides and you have 7x is equal to 14. Divide both sides by 7 and you have x is equal to 2. Now don't get excited. We are not done. All we have so far is x. When solving systems, you need to find both variables. So now we need to go find what y is equal to. Well, we know what x is. So let's just go back to that equation we found. And we're going to substitute 2 in for x. So now we have y is equal to a negative 2. And remember, whenever you're substituting in something, you should use parentheses. Instead of x, we need to substitute in a 2. And then, of course, we have plus 5. So y is equal to a negative 4 plus 5. So y is equal to 1. And, of course, you're not done. You have to write it properly. The proper way to write a system solution is x comma y, just like a coordinate. So 2 comma 1. And now you're done. That's it. That's how you solve a system by substitution. Now, when you're solving by elimination, you're still going to get the same answer, but the process is a little different. Okay, so what you need to do with elimination is you want to eliminate a variable by multiplying. There's a couple of different ways. You can get x to disappear, you can get y to disappear. But what you need is opposite coefficients for either one of the variables. So can you multiply 2 to get 3? Not without using a fraction. Can you multiply a 1 to get a 2? Yes, easily. But you want 1 to be positive and 1 to be negative. So we can multiply this y by a positive 2, and that will be opposite of a negative 2. So the first step is to multiply this entire equation by a positive 2. So 2 times 2x is going to give us our 4x 2 times y is going to give us our 2y, equals 2 times 5 is going to give us 10. Now when you do that, you just need to add these two equations together. So 3 plus 4, x is going to give us 7x, and negative 2y and 2y are going to cancel each other out. That's why we want opposites, and now the y is gone. And then 4 plus 10 is 14, and it's the exact same thing as substitution. See, we have 7x equals 14, 7x equals 14. It's just a different process. Divide both sides by 7 and you still get x equals 2. And this time you don't have an easy one where y is equal to something and all you have to do is substitute it in. But we still have to substitute this 2 into one of the equations of your choice. So it really doesn't matter which equation you choose. So I'm going to choose the less likely one just to show you that if we have 3x minus 2y is equal to 4, you're still going to substitute x into the x variable of this equation. So 3 times your 2 minus 2y is equal to 4. So 6 minus 2y is equal to 4. Subtract 6 from both sides, and that gives you a negative 2y is equal to a negative 2. Divide both sides by a negative 2, and you still end up with y equals 1. And just like the previous equation or example, you need to write it as an ordered pair, 2, 1. All right, that's solving systems of equations. So you watched me do it. Now it's time for you to pause the video since you've already worked with these before and try these two on your own. Now again, it doesn't matter to me which way you want to do it, but as I mentioned earlier, sometimes it's easier to use a certain method. So if you look at this equation right here, y is equal to 3x plus 11, the y is all by itself. In this one, we don't have any variables that are by themselves, and they're not very easy to get one by themselves. So the obvious choice for the first one is substitution, and your obvious choice for the second one would be elimination. However, if you want to manipulate these in some sort of fancy way to do your favorite method, it'll still work out as long as you do the steps correctly. All right, so pause the video, try these two on your own. As soon as you're ready, click play, and we'll see if you got them right. So for this guy, we have our 4x plus 3. And then I'm going to use substitution. So I'm going to substitute 3x plus 11 into my y value. And that's equal to a negative 6. Distribute. So 4x plus 9x plus 33 is equal to a negative 6. Combine my like terms. I have 13x plus 33 is equal to a negative 6. Subtract 33 from both sides. And we're going to have 13x is equal to a negative 39. Divide both sides by a 13, and x is equal to a negative 3. Now that I have my first variable, I can go back and substitute this into the y equals, which stands alone. So y is equal to 3 times a negative 3 plus 11. So y is equal to a negative 9 plus 11, which means y is equal to 2. So our final answer for this first example is going to be a negative 3 comma positive 2. In our second one, we need to eliminate x or y, unless you chose to do this using substitution, which would have given you a fraction. We need to multiply the top by a positive 2, because a positive 2 times 2 is a positive 4, which will cancel our x's. Again, it doesn't matter which order you want to go. So we're going to multiply this top one by a positive 2. That's going to give us a 4x plus 10y is equal to 2. And now we're going to work with these two equations. Now there are times where you need to multiply both. the top and bottom to eliminate. It's fine. It'll work out. You could have multiplied the top by a positive 4 and the bottom by a negative 5 to get the y's to cancel. It doesn't matter. So after we do that, we're going to add. So negative 4 and 4 cancel. That's the whole point. And then we're going to end up with 14y is equal to a negative 2 plus 2 is 0. So divide both sides by 14 and y is equal to 0. That doesn't mean this is no solution. It means y equals 0. So then you go to either one of your equations, 2x plus 5, but y is now equal to 0. And that's equal to 1. So 5 times 0 is 0, so this gives us 2x equals 1, so x is equal to 1/2 after you divide both sides by 2. So now our equation is done. We just have to write it as our x, 1/2 comma y, which is 0. Now, one of the things you should do at the end of every system is substitute these answers back into the original equation to make sure your answers are correct. But you should do that for all solving. So if you were to take the negative 3, substitute it in here. 3 times a negative 3 is a negative 9 plus 11 is y is 2. Done. Negative 3 times 4 is a negative 12 plus your 3 times 2 is 6. Negative 12 plus 6 is a negative 6. Hooray, it works. Same with this. 1/2 times 2 is 1. 5 times 0 is 0. 1 plus 0 is 1. Just make sure your equations work after you substitute in the solution, and you are good to go. That's how you can check your work. All right, this is Longo, and I'm out. See you, bye.